At number 5, its punaste galaxy. Galaxies are immense, countless stars set in an image painted by nuclear processes and gravity. They're so overwhelmingly large and luminous that we can see many of them with the naked eye across great distances, so it's easy to forget that galaxies can be found at the opposite end of the size spectrum as well. Segue 2 is an example of how something small can take us by surprise, because it only contains about 1,000 stars. For contrast, our galaxy boss number in the hundreds of billions. The combined output of the whole galaxy is only about 900 times greater than our Sun. Quite underwhelming considering our own star isn't especially large or impressive on a cosmic scale. As the capabilities of our telescopes improve, we might find more outliers like Segue 2, which is great for math, because galaxies of this size were predicted but never observed until. At number 4, its largest impact crater. Ever since we've been studying Mars in appreciable detail, there's been disagreement about what caused the planet's hemispheres to look so dissimilar to each other. A new-ish theory states that the disproportion is due to an immense catastrophic impact that changed the face of the planet. The Borealis Basin offers clues to Mars' tumultuous past, as this is the largest crater, so far, in the solar system. It covers a large portion of the planet, at least 40%, spanning an area 8,500 kilometers, 5,300 mi, across. The second largest crater is also on Mars, yet is 4 times smaller. To have produced such a large crater, the ancient impact must have been absolutely otherworldly, with the offending projectile calculated to have been L. At number 3, its closest perihelion in the solar system. While Mercury may be the closest large object to the Sun, there are plenty of smaller things that get even closer. Perihelion is the point in orbit nearest the parent star, and Asteroid 2000 BD19 has the smallest orbit, getting incredibly intimate with the giant, hot ball of nuclear explosions that keeps us warm and alive. Since the perihelion is only 0.09 to astronomical units, 1 or is about how far the Earth is from the Sun, on average, HD19 gets hot, really hot actually, reaching temperatures that could melt zinc and other metals. Studying this asteroid is important because it helps us glean how different factors can shift a body's orbital orientation. One of these factors is Einstein's famous theory of general relativity. Therefore, careful scrutiny of this near-Earth object can help us see how this amazing theory relates to. At number 2, it's extremely old quasar. Some black holes are extremely massive, and that's to be expected, because they ingest anything that gets in their way. 2 billion solar masses, ULSJ 1120 plus 0641 was a huge surprise for astronomers, not necessarily due to its magnitude, but due to its age. ULS is the oldest quasar, basically a black hole puking into space, ever found. It appeared less than 800 million years after the Big Bang. That's absolutely ancient, and it means that the light from this distant quasar had been on a 12.9 billion year intergalactic voyage before it arrived here on Earth. No one's sure why the black hole is so big, since there wasn't much of anything for it to eat. At number 1, its lakes on Titan. With spring emerging and winter clouds retreating, the Cassini probe was recently able to get some great snapshots of the lakes littering Titan's North Pole topography. Water cannot exist in this alien landscape, but the temperatures are just right for liquid methane and ethane to flow and emerge from the moon's interior. Oddly enough, this is the first time the clouds have lifted enough to offer a clear view of the pole, even though the Cassini probe has been orbiting Titan since 2004. The main lakes are each hundreds of miles wide, with the largest, Kraken there, the size of the Caspian Sea and Lake Superior combined. The existence of a liquid environment was integral for the formation of life on Earth. But seas full of hydrocarbons are a completely different animal, since material can't dissolve in the substance as well as it can in water.